All right, so, yes, it's due Monday morning, but I'm going to do the first two today and the other two tomorrow. Okay, so if you guys have been practicing graphing or you're trying to figure it out, we're going to go through the steps of graphing rationals. You will have a bunch of questions on your test. I'm going to give you a rational and say, okay, here is this rational, find the domain. Here is a different rational, find the vertical and horizontal asymptotes. Then there's going to be one or two that says, here's a rational function, find all of the stuff, and then graph it. So you need to be able to locate all of these things, figure them out algebraically, and then put it on a graph. So first thing I want to bring to your attention is zeros. What's another thing that zeros is asking you for? X-intercepts. Okay, so make sure that you understand zeros is the same as x-intercepts. We're always going to write our intercepts as ordered pairs, especially since we're putting them on a graph. So make sure that you're writing your x-intercept and your y-intercept as an ordered pair. Now, when we're graphing, I think the best thing to do, and again, you don't have to do everything I say, but the best thing to do when you start off and you're trying to graph one of these rationals is to factor from the beginning. So I'm going to go ahead and factor. I have 8 on top and then on the bottom. Can I factor? -6. I multiplies to give me -6, but adds to give me 1. X plus 3, x minus 2. Okay. Now, now that we've done this, we've figured out a bunch of stuff because we're going to have to factor the denominator anyways to find your vertical asymptotes and your domain. But you're also now identifying if there's any holes. Is there anything on the top and bottom that is exactly the same? No. So there's no holes in this graph. So go ahead down to holes and write none. You already know there's no holes. There's none. Get that out of the way. Now, since we have factored the bottom, we can now determine our vertical asymptotes. We're going to set each piece equal to what? 0. Good. X minus 2 equals 0. So you have a vertical asymptote at -3 and a vertical asymptote at +2, correct? So x equals -3 and x equals +2. You've also now determined your domain. You know there's absolutely no holes. And you know there's 2 vertical asymptotes where the graph does not exist. So what is your domain based upon your vertical asymptotes? -infinity to what? -3, good. Union, -3 to 2, union, 2 to infinity. Somebody asked me last period, do you always do the smaller number first? Yes, because think, guys, we go left to right. If you're confused, which could happen if you have a fraction or you have 2 negative numbers, think about a number line. -3 would be here and 2 would be here in relation to 0, right? So if you're working left to right, you're starting at -infinity and then that goes to the -3, then the gap in between there, and then from 2 to infinity. So just to give you like a visual if you wanted to see it that way. All right, we good? Let's look at the next thing then. And you can go in whatever order you want to. I'm just going to now go to my horizontal asymptotes. How do you guys find horizontal asymptotes? Good. You compare the degrees, numerator degree to the denominator degree. There was one of these on WebAssign, guys. If there is not an x, you can put one there, and it's x to the 0 power, correct? So what is the degree of the numerator? 0. The denominator is 2. 0 is what than 2? Less than. Perfect. So what do you know if the numerator degree is less than? What's your horizontal asymptote?
0.
At y equals, good, 0. If you have a horizontal asymptote, what do you know you don't have? Slant. So you can go right here and say, oops, there's none. The only time you have a slant asymptote is when you do not have a horizontal. Right? If you have a horizontal, then you don't have a slant, and vice versa. If you don't have a horizontal, then you do have a slant. So we've answered a whole bunch of questions just by kind of factoring the denominator. So now let's think about the 2 things left, your intercepts, guys. You find them separately. You find them differently. To find the x-intercept or the zeros, x-intercept, we set what equal to 0?
Y.
Nope.
Yeah, second and third lunch, I forgot.
Okay, how do you figure out the x-intercepts? You set the numerator equal to 0. So this says 8 equals 0. Is that true? No. So does this have any x-intercepts? No, so you would say none. So that is very helpful, guys, graphically. So you know when you go to graph this, it's not going to do what? It's not going to touch the x. Good. Now your y-intercept, how do we find y? No. How do we find the y-intercept? You're going to plug in 0 for all x's. To find your x-intercept, it's the numerator. To find the y-intercept, it's everything. So if I plug in 0 to everything, I have 8 over 0 squared plus 0 minus 6. So I have 8 over negative 6, which reduces to negative 4/3. So this is going to touch the y-intercept at 0, comma, negative 4/3. Now, when you guys have intercepts that are not 0, 0, it's very helpful. Kind of gives you a good guide of what your graph should look like. So now this is how you fully graph. You've answered all the questions. So now let's just put it all on the graph. The first thing I like to put on are the asymptotes. Where are our asymptotes? Where are my vertical ones? At -3 and +2. So I'm going to come over here to -3. You guys are welcome to bring color pencils if you want to. Sometimes it's helpful. You want to bring different colored pens. I don't care. But remember, your asymptotes are just boundary lines. They're just dotted lines. Your graph will never, ever, ever touch which ones? The verticals. Never. They could cross over the horizontal, but they'll never touch the vertical. So what is your horizontal asymptote? What did we determine it to be? Y equals what? 0. Okay. Some of you are going to be like, can you tell if I wrote it? Go ahead and just extend it a little farther left and right, and then I'll be able to see. So we have now created our sections to figure out where our graph occurs. Do you guys agree? Do you understand on the left? There's a section here and a section here, above and below the horizontal. On the right, there's a section here and a section here, above and below the horizontal. The middle's a little different. We have to check a few points in the middle to figure out what the shape is going to be, whether it's going to be a parabola looking or a snake looking thing. But we'll determine that in 1 second. Hang on. All right, so the last thing I think that you should plot before you start plugging points in are your intercepts. Where does this graph cross the y-axis? No. So that's helpful information. Why is that helpful? So that means it's either going to be a parabola like this or a parabola like this, because if it does not cross the x, it won't go like that. So that's a good thing to know. Another good thing to know is where the y-intercept is. Where does this graph cross the y? At 0, negative 4/3. So it's here-ish. So right now, you guys can already determine where the parabola exists in this case. Is it above the horizontal or below? It's below. How do we know that? Because we know it does not cross the x-axis, and we know it crosses the y there. Just little things will give you hints on where your graph, what it should look like. But let's start to the left. Let's see if our boomerang occurs or exists above the horizontal or below. So pick any number on the x-axis that is less than -3. Less than. It's got to be over here. Pick a number. -4. Okay. So I'm going to plug in -4 and see what I get out. So I go to my original. I have 8 over -4 squared plus -4 minus 6. So we have 8 over, what's -4 squared? 16 minus 4 minus 6. What's 16 minus 4? 12. And what's 12 minus 6? So you get 8 over 6, which reduces to 4 over 3. So 4 over 3. So -4 and 4/3. Is that above or below your horizontal? It's above. So you know that your boomerang is going to exist right here. Somebody asked me, how do you know how to draw it? You want to stay real close to the asymptotes but not touch the vertical. If I would have plugged in -4 and gotten a negative number, where would your boomerang have existed? Above or below the horizontal? If I would have plugged in -4 and I got a negative number, where would my boomerang have existed? Below. That's how you guys figure that out. So let's go to the right. Let's go to the far right. Let's pick a number bigger than 2. What number do you want to use? 4. Okay, we'll use +4. That's fine. If you use 3, that's fine. If you use 10, that's fine. So if I plug in +4, I have 8 over 4 squared plus 4 minus 6. So 8 over, what's 16 plus 4? 20 minus 6 is 14. You guys don't even really have to simplify this. If you do, great, 4 over 7, right? But you need to think about where that point is. +4 and 4/7. Is 4/7 above the horizontal asymptote or below? It's above. I go 4 and 4/7. It's somewhere up here. So where does your boomerang exist? Is it above the horizontal asymptote or below it? It's above it. So just draw something that goes along here. My thing for you guys when you're graphing this is that you're in the right section and you don't touch your vertical asymptotes. It's actually helpful that we had to move the test because I think we can graph a little extra and be helpful. Now, where do I already know that my parabola exists for the middle section? Is it above or below? It's below. Now, some of you would say, how do you know? How do you know to draw? How do you know it's not a snaky thing? Let's pick numbers to the left and to the right of 0, right? Something in the middle. Let's pick 2 numbers that are in the middle of our asymptotes. I'm going to pick -1 and +1. So if I plug in -1, let's see what I get out. When I plug in +1, see what I get out. So I have 8 over, it's -1 squared, -1, is it -6? -6. So this is 8 over, what's 1 minus 1? 0 minus 6, this gives me -4/3. Where is -4/3? Is it above or below the axis? It's below, so it's here-ish. If I plug in 1, 8 over 1 squared minus 1 minus 6. Do I get the same thing? -4/3, so it's here-ish. Do you guys see where your parabola exists? So then you just draw a little parabola. Don't touch your vertical asymptotes. Don't touch them, but just get in there. So you get the general shape. You get the general idea of what your graph looks like. That's what you should end up with. Questions? This? 3. Really and truly, the only thing that matters is that you realize that this is negative, so you know it's below the x-axis.
When you plug in the positive, literally 1 squared plus 1 minus 6.
So 2 minus 6, still going to give you -4, right? So it's be -2. What's the important thing is that it's where? That it's below. You've got to know the general areas. It's below the horizontal asymptote, so you know it's going to exist there. But you're right. I wrote, yeah, because it was negative. This should be 1 plus 1 minus 6. So it's 8 over -4, which is -2. Thank you, ma'am. All right, so it's important, guys. You have to be able to practice this. If you have one of these on your test or 2, you cannot take 15 minutes to go through this. You have to be able to run through the list, know where to look for stuff, and be able to evaluate. If you're sitting here and you're like, oh my gosh, I just don't get this, you have to practice it more. You have 3 more on here. I'm going to do the next one, but there's some that are going to be on your test review. Try them on your own. It's much harder to do on your own than it is for me to walk you through it. So try it before you come in here and we can talk. All right, let's go to the second one. I want to do this one and then we'll do the other 2 tomorrow. Again, remember zeros. Whoops. Zeros is another way to say what? X-intercepts, okay. So let's factor first. Let's factor the numerator and the denominator so we can kind of see, because we're going to have to end up doing that anyways. But let's see if there's any holes. So in my numerator, do you guys agree I can factor out a 2? Then I'm left with x squared plus 5x plus 6. I'm going to take out that 2. And then that factors into what? X plus 3 and x plus 2. Yes? Okay. And then in the bottom, when we factor, what are the factors of positive 2 that multiply to give me 2 but add to give me 3? X plus 1 and x plus 2. All right, so now that we have done this, we factored, we can find asymptotes and all that stuff, but what do you guys notice? There's a hole. There's a x plus 2 and an x plus 2 on the top and the bottom. So right away, you guys can tell me, oh, wait, there's a hole at where x plus 2 equals 0. So you have a hole at x equals negative 2. So you have a hole at x equals negative 2. Now, guys, remember, you have a hole. That means if there is an asymptote there as well, you do not account for that asymptote because it's not an asymptote, it's actually just a hole in the graph. So let's talk about how we would find our vertical asymptotes. What would you guys do? You set the denominator, what? Equal to 0. So we've already factored it, so you have x plus 1 equals 0. X plus 1 equals 0, and you have x plus 2 equals 0. So you have here, x is negative 1, and here you get x is negative 2. But you already know that you can't use negative 2 as an asymptote because it's what? It's a hole, so cross that one out. That doesn't count as an asymptote. It's a hole in the graph. So your vertical asymptote is at x equals what? Negative 1, okay? Let's talk about our domain. Based upon our vertical asymptote, what's our domain? Negative infinity to negative 1, union, negative 1 to infinity. We're going to revisit that in a minute. All right, so let's move on. Let's find some other stuff. Let's do our horizontal asymptotes. How do you find your horizontal asymptote again? Okay, exponent, numerator degree to the denominator. So it's 2 equals 2. So what's our horizontal? At y equals 2. It's not because the degree is 2, guys. It's the leading coefficient of the numerator over the leading coefficient of the denominator. So your horizontal asymptote is at y equals 2. What does that tell you about your slant asymptote? There isn't one. If you have a horizontal, you do not have a slant, and vice versa. So let's now talk about our intercepts. How do you find the x-intercept? X-intercept, you set what? Numerator equal to 0. Well, we've already factored it, correct? You guys agree we've already factored it? So set each piece equal to 0. 2 equals 0, x plus 3 equals 0, and x plus 2 equals 0. Does 2 ever equal 0? No. Okay. So this is x equals negative 3, and this is x equals negative 2. But wait a second. Haven't we had x equals negative 2 already? Where have we had x equals negative 2? It's a hole. So guys, if there is a hole in the graph at x equals negative 2, could that also be an intercept? No. So you can cross that one off. So our x-intercept is at negative 3, 0. Now you'll see, once we figure all this stuff out, this makes your graphing really easy once you identify the stuff. The last thing we need to do is our y-intercept. That's where the graph crosses what? The y. How do we find y-intercept? You plug in 0 to everything. So 2 times 0 squared plus 10 times 0 plus 12 over 0 squared plus 3 times 0 plus 2. Well, what happens with 0 squared times 2? 0. And then what's 0 times 10? 0. So you're left with 12 on top. 0 squared plus 3 times 0, you're left with 2 on top. What's 12 divided by 2? 6. So this graph crosses your y-intercept at 0, 6. This will be real easy to graph because you've identified all this information. Where is your vertical asymptote? Negative 1 at x equals negative 1. So I'm going to go here, negative 1. There's my vertical asymptote. Oh, that's too big. Where's your horizontal? at what equals 2? Y equals 2, okay, so y equals 2. So do you guys see here, we don't have 6 sections, we only have 4 sections. We got one here, one here, one here, one here, yeah? So to the left of your vertical asymptote, your graph is either going to be here or here. It won't be in both spots. So you got to figure out above or below. But before you start plugging in points, let's go ahead and plot our intercepts to see if that helps us locate our graph. Where does the graph cross the x-axis? At -3, 0. So crosses here. What do we know happens at -2, 0? There's a hole, right? Okay. And then where does the graph cross the y-axis? At 0, 6. So 0, 1, 2, 3, 4, 5, 6. Do we already see where our graph exists, guys? The one on the left, is it above or below the horizontal asymptote? It's below, so it's going to come like this, look. And what does that hole mean? It means it goes there, and then it comes out of it. It does not touch that hole. That looks like a straight line, and it's not. It's supposed to be like... So you're going to draw your boomerang, and it does not touch your vertical asymptote. If you get close to the horizontal, that's fine. Some of them might cross, some of them might not. This one does not. And then where does the one on the right side exist? Is it above or below the horizontal asymptote? It's above, because you know that there's an intercept there. So it's just like this. Now I said I was going to revisit domain. How come I need to revisit domain? I agree with negative infinity, -1, and then -1 to infinity. There's a hole. Where is the hole? At -2. So really and truly, this would be negative infinity to what? -2. Then what? -2 where? To -1. Then where? Then -1 to infinity. Do you see why we had to revisit domain? Because there's a what in the graph? There's a hole. Good. Now, you guys are not... Now, I understand, guys. I understand this is like, whoa, this is a lot. I get it. That's why we have spent this entire week just going piece by piece with everything. We've done this before. We do it in 2 days, and it's overwhelming. So that's why I broke all of the notes into little pieces, and then it actually is helpful that we push the test back because I wouldn't have gotten through all 4 of these in one day. So tomorrow we'll do the next 2, and it's going to look, both graphs are going to be a little different. One has a slant asymptote, one's going to have a little snaky thing in the middle instead of a parabola, so you guys can get some extra practice. Your test review has a bunch of these on it as well to give you guys the extra practice. Please don't wait until Monday in class and try and just cram everything in because you guys need this extra practice. I hear all the time, I don't know what to do. You guys can't study by just staring at the notes or listening to my video again. You actually have to actively practice doing this because the process is the same every time. Every time to find the zeros, you set the numerator equal to 0. Every time to find the vertical asymptote, you set denominator equal to 0. Like the process is the same, but in each problem, the numerator is different. The denominators are different. The factoring is different. So you have to be able to adapt to all the different kinds of things you're going to see. It's not just, oh, I memorized this and I'm going to spit it back out. So you guys actually have to actively practice. All right, we good? Okay.